Okay, all right. Let's start with chapter 17, tutorial 17. Question 12. See, we finish off the sequences and series first, and then I'll take a look at. We'll go back and take a look at complex numbers. Okay, can okay. So let's take a look at this first. So the sum of the first n terms of a series is n cubed minus 11n squared plus 4n, where n is a positive integer. Find an expression for the nth term of the series. So once again, this is Sn, right? We are looking for expression for the nth term. We are looking for un, correct? Sequences and series. Sorry. Yeah, I finished this first. Yeah, then I go back to complex number. Okay, sorry. Okay, so Sn and Un. So what do we do? Same thing, lor. So your Un, right, or your Tn will be equals to Sn minus S of n minus 1. Okay, so let's try. Okay, so this Sn will be just like that, right? Then minus of S of n minus 1. So we have this cube minus 11n square plus 4n. Okay, something like that. Can So let's do this in a very fast way. So n cube, okay, not say very fast, but n cube minus 11n square plus 4n minus, okay, this one very quickly, n cube minus 3n, wait, okay, n cube minus 3n squared plus 3n plus minus 1 minus 11n squared plus 22n minus 11 plus 4n minus 4, something like that. Okay, so this one is a very speedy way of doing it. Then I think lo and behold, right, you continue on, you should be able to get 3n squared minus 25n plus 16. Okay, can so this one to do cut shortly, this one is use your binomial, okay, binomial, but binomial expression for cubic. Okay, 1331. Okay, so this one I won't spend so much time. Okay, the second one is something that I want to spend a bit more time. Okay, so the sum of the first m terms of the series, okay, where m is this. Okay, so sum of the first m terms of the series, m is this, is equal to the sum of the first three terms of the series. Okay, so find the value of m. Okay, so given, okay, so sum of the first m term will be equals to sum of the first three terms. Okay, then m will be greater than 3. So over here, right, what happens is we'll make use of the sum formula. Okay, so this one will be m cubed minus 11m squared plus 4m equals to 3 cubed minus 11 times 3 squared plus 4 times 3. So altogether, m cubed minus 11m squared plus 4m plus 60 equals to 0. Then you check the amount of marks, right? This one just 2 marks, right? Correct? So 2 marks, do you need to solve from scratch? Don't need, what do you use? GC. So using GC, m would be equal to -2, 3, or 10. Okay, so since m is greater than 3, so m will be equals to 10. Okay, so something like that. Can Okay, so at the end of this chapter, right, I think we've come to the end, and I think we can close this chapter off. Okay, this chapter, right, what I want to tell you is it's not easy. It's not the easiest chapter because you have to be very detail oriented to see you sum from where to where. The notation is scary. More often than not, involves fraction, factorial, and powers. Okay, um and yeah, so this chapter is not that easy lah. Okay, but what I want you to realize is something that you, whenever you see what are the signs where you see that you need to do, pick up stuff from this chapter. So this chapter once again belongs to sequences and series. Okay, sequences and series, right? So under sequences, right, you already learned AP, you already learned GP last time. And in EMAth, right, you already learned your number patterns. Okay, technically speaking, right? So now, right, we are going to add one more thing over here, which is your recurrence relation. Okay, recurrence relation, and then things involving UN or maybe things involving A sub N kind of thing. So all these are sequences. Okay, and then we look at the behavior, we look at the convergence, divergence, we find the patterns, we find the nth term, find the general term, and so on. So we do all these things with sequences. Okay, so for example, when you come to this question over here, right? Okay, I quickly shift up. Okay, so if you look at this kind of question, right, this is under sequences and series. Sequence, series, right? Sequence kind of thing. Okay, so you just need to be very comfortable that when you see sequences and series, then or when you see things like V1, V2, Vn plus 2, Vn2, Vn plus 1, that kind of thing, right? You activate your sequences and series brain already. Okay, but sometimes you need to sum, sometimes don't need to sum. Okay, just make sure that you see this, right? All these belong to sequences. Then here you handle a series question. Okay, so this is the first one. Okay, now the second thing I want you to realize that series, right, is actually your AP-GP sum also. Okay, okay, but at the same time, right now we expand this to the sigma notation. Okay, we expand this to sigma notation. Okay, so then over here you have your Sn, you have your Sn infinity, right? And then how does the Sn and S infinity, right, link to the sigma notation? How is it presented in the sigma notation? I hope that's one is something that we need to consider also. Okay, can so yeah, okay. So technically speaking, yeah, this chapter will throw you a lot of new things. Okay, but the things I believe you can handle after more exposure. Now you're feeling difficult because you're seeing these questions for the first time, right? And all these are exact A level questions. Okay. But what I want to encourage you is that by more exposure, I believe that you'll be more confident with this topic. It's difficult, but it's not as technically difficult as vectors, if you get what I mean. The difficulty lies in the detail and the ability to do the algebraic manipulation. Okay, and to understand what is the context of the question, because the context is rather abstract. There's no storyline. Okay, there's no graph, it's just very dry context, very abstract context. Okay, so yeah, but then again, it is not as challenging as things like vectors are. Okay, so still pretty doable. Okay, still pretty doable. Things like this. Okay, things like this. Okay, and even things like this also, right? Because let's say if they give this, right, you may not know where to start from or which topic to start from, correct? But how do I know that I need to tap on sequences and series brain? Is actually U1, U2, U3, Sn, UR, AR, AN plus 1, AN. So all these are terms of the sequences that we will need to use, and then we do find the series, sum of the terms in the sequences, something like that. Okay, can so how do I know that I need this topic is by looking at signs for AN plus 1, AN, and so on. Okay, can